looking at area formulas. Area of a parallelogram. Remember what those look like? Areas. I think it's all right. So what happens with the area unit? It's technically chapter 10, but this unit starts in chapter 1. It's just not smile. It's sure. We're starting. We'll just call it the area unit. There's something. We're just going to kind of list through a couple things to start out with. And honestly, it takes about 15 minutes to go through what I have. And I've got some problems you guys to start working on. And you just start working on some algebra stuff. So today we're going to look at the areas of a parallelogram, the area of a rectangle, area of a square, area of a triangle, area of a trapezoid, area of a circle. And all of these you kind of probably already know, and you might have just forgotten a little smidge here and there about certain parts. Now, when we're talking about this whole thing with the parallelogram, I'm looking at this thing with the parallelogram. Remember a lot of times we drew parallelograms that looked like that? Yeah, draw it. And it's a circle. Those are all my little bad symbols. Sorry. We talk about the area of a parallelogram. When you're looking at these things, you're talking about bases and heights. And whenever you're talking about bases and heights, that means it's going to be where you have things that are perpendicular. So what you're looking for are your verticals and your horizontals. In parallelograms, a lot of times what they do is they draw them in with dotted lines. I'm sure you've seen that before, correct? Where this becomes your height, and whatever portion that it's perpendicular to is the base. You'll see that. So an area of a parallelogram is just base times height. And guess what? Guess what a rectangle is? A parallelogram, so it is. And isn't a square a parallelogram? So it's also base times height. So it's really nice to see that this is super, super easy math stuff that I know that all of you guys have done. So the rectangle, base times height again. Square is base times height, but in a square, since all the sides are all the same, a lot of times what they do is just say side squared. I'm sure you've seen that before, right? Yes, no, maybe so.
Yeah.
Or those are all the same. Huh?
It's spelled height wrong.
H-E-I-G-H-T?
It didn't look right.
Height, right. And then when you get to, excuse me, I'm sorry. We're out cleaning out all the garage and all that wind and all the dust from the whole winter has gotten into me now. Triangle. What's the area of a triangle? You know this. It stands for the side, because in a square all the sides are the same. So you just say side squared, or if your sides are all 8, it can be 8 times 8 anyways. They just write it as 8 squared. The triangle, it's 1/2 the base times height, or base times height over 2, however you want to write it. One of the things that I will say that students tend to forget about when you're talking about triangles. When you're talking about triangles, you basically have 3 different versions of what they look like. You have your right triangle, which is very easy to tell where your bases and heights are because it's always where the right angle is formed. So those are your bases and heights. When you have an acute triangle, a lot of times the heights are drawn on the inside of the triangle. So you'll see that dotted line being drawn downward. So there's your height, and then that makes this entire section the base. Remember, the base and the heights are the 2 segments that create the right angles. Bless you. And then the weirdest looking of one of them is when you have that obtuse triangle, where a lot of times you get the height that's drawn outside of it. I'll show you an example, you guys will catch on right away. A lot of times if you have an obtuse triangle, they'll draw that height part, that perpendicular with the dotted line on the outside. where this is your height, but it's this section here is the base. Not the portion outside of it, because it's not in it, it's the portion that's in the actual triangle. It's one of those weird ones that people tend to forget about. I just wanted to re-show that to you real quick. Excuse me. Does that vaguely look familiar? Like I said, bless you. Trapezoids. What do trapezoids look like? Me? So trapezoid had one set of parallel sides. Trapezoids are ones that you'll see a lot of times with trig, because they'll give you one of the base angles and make you use SOHCAHTOA or something like that to figure out a height. But what they're looking at here is these guys are called bases. When you have trapezoid, you've got two bases. The bases are the ones, are the parts that are going to be parallel to each other. The other ones are just the legs. When we talk about the area of a trapezoid, we still have to figure out the height. And the height's always going to be drawn with the right angle. So the area of a trapezoid, you remember this from years ago, 1/2 the height times the sum of the bases. Okay. There's a bunch of ways. I mean, there's other ways of doing it, but this is the most common one you'll see. Sometimes people take the trapezoid and they draw it and they create two triangles and a rectangle in between. If you want to do it that way, that's fine. It's a little bit more work, but it does work. And you go from there. But yeah, there's your area of a trapezoid. For any of these shapes that we just talked about, how do you find their perimeters? Remember that? Yeah, you always have the outsides. Remember the printer. The printer is out there. It uses ink and toner and stuff. But the perimeter is the distance around an object. When we're talking about in terms of units, when I have areas, our units are always squared, very good. And if it's perimeter, it's just whatever the units are. We're just adding. You guys all remember that, right? No? Well, I'm glad I'm here to help remind you. I know that. I couldn't tell from the sarcasm. You guys have a good weekend? Yeah. It's nice to be outside. Very windy. That's why my eyes were so shocked about that windy outside all weekend. Clean up my yard. You know how in your garage, after you have all the snow melts and you get all the junk from your cars all over your drive, all of your concrete, so it's all dust and dirt and all that. We pulled out all the kids' toys and stuff and just swept everything out, and all that wind, it just kept blowing around. So my allergies are clogged up, my eyes are still puffed out from all that dirt. I should have worn my contacts in it, but whatever. But it's great to be outside. Got to go on a motorcycle, wonderful. Good times. Both days.
Where did you ride?
Wherever I want.
She thinks she saw you. Yeah, that's why she's asking.
I saw a bunch of people on motorcycles past couple of days. I was mainly up on the north side out here.
Like Mr. Rouse, like ride his
Little scooter?
Yeah.
Mine's a little bit faster.
a little bit.
Then we get to the weird stuff. Circles. When you have circles, you have to worry about a couple of parts. Remember what this is called? The radius. Good. The radius is the segment that's drawn from the center of a circle to a side. Now, inside circles, what do you know about all the radii? Yeah, exactly. And that's how you define a circle. A circle is defined by a set of points that are all equidistant to a center point. Those set of points are around the periphery of it, and that equidistance portion comes into play from the radius. That's how you define out a circle. Now you have this radius, Also inside of a circle, you have something that's called a diameter. Now, the diameter, a diameter is actually something that's called a chord. You ever heard that before in terms of a circle? A chord in a circle is a segment that has endpoints on the circle. Right. Whereas the radius has one endpoint on a circle, the other endpoint's at the center. A diameter has one endpoint here and one endpoint there. So the endpoints of the actual segment are on the circle. Now, a diameter is just a fancier version of a plain old boring chord. A chord, which we'll get to later on, could just be something like this. Okay? That was technically a chord, but we're not worried about that with areas right now. We'll come back to that when we get back to circles. So the diameter is made up of two what's? Yeah. So the diameter, if you remember, is equal to double a radius, or you take half of a diameter and you get diameter there. You take half of the diameter, you get the radius. If your radius is 4, your diameter is correct. And if your diameter is 12, your radius is, and so on and so on and so on. This wasn't anything crazy. Now, in order to find the area of a circle, do you remember what you had that you had? What was the area of a circle? What do you think? Well, all right, let's go back to this then. Let me show you this. How many degrees does it take to get around a circle? 360. So to go all the way around a circle is 360. If I start here at 0, go all the way around, I end at 360. Everybody okay with that? If I start at 0 and I go halfway, how far did I go? 180. What's half of 180? 90. What's 90 plus 180? Okay. See where I'm going with that here? So every time you turn 90 degrees, you take up a quarter of the circle. All right, that? Anyway, when you talk about going around an object, you go around it 360 degrees. If I want to talk about the length of this to go around an object is called the circumference. You guys remember that? Heard that before? The circumference is dealt with in terms of a radius, 2 times the radius times pi. So you have the circumference is 2 pi r, where circumference is the distance around a circle with a given radius. Okay. Now, excuse me, if I say that my radius is 1, what's my circumference to go all the way around that circle? My radius is 1, it would be 2 pi. Okay with that? Watch what happens. If this is 0, this is 2 pi. What's half of 2 pi? 1 pi. What's half of that? What's half of 1? Or 1/2? What's 1/2 plus 1? 1 1/2, so 3/2. What's half of 90? 45. If I count by 45s, 0, 45, 90, 135, 180, 225, 270, 315, 360. If you count by 45 degrees to go around a circle, how many sections are there? Well, 1, 2, 3, 4, 5, 6, 7, 8. Everybody see that? Now this is where, you don't have to write this down, this is where math gets crazy. 45 is a quarter of the circle. I'm sorry. Excuse me. It's 1/8 of the circle because to go all the way around, We had 8 sections. What's half of a half? A quarter. So here's 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. This is what happens as you get into Algebra 2. We start talking about all of this, and I made mention about this before. But your 2 triangles, the 45, 45, 90, and your 30, 60, 90, is why trigs. It's why all of this stuff that we've been talking about works, because you can break everything down because of this thing called circumference. Okay? It's why everything works later on. But again, you don't need to worry about that. What I want you to remember is this. That was smooth. The circumference is equal to 2 pi r, or what's another name for 2 times r? Diameter. Sometimes I'll write it as circumference equals pi times the diameter. And then the area of a circle, remember that one? Pi r squared. We've all seen this before. Okay. My parents thought it would be funny when I graduated from college with my degree that they baked me a square apple pie. Nice, where I got my humor. Yes, Kleckner, you just got it. Thank you. Thank you. Yeah. She's sitting further away from you, so sound travels and it takes longer to get to a spot. 4. Or 22. Put 2 and 2 together. Morning, Kleckner. How are you? I don't know. So like I said, a lot of this stuff is so much review. I know that all of you guys have seen all of this before. What's going to be a little bit different today is that I'm going to ask you guys to do something like this. Can you figure out can you use an area formula to solve for a missing piece? For example, find the length of the second base of a trapezoid. If one base measures 12, the height is 4, and the area is 58 square feet. Which means, what shape are we working with? Trapezoid. So, we're talking about area of a trapezoid. So the area of a trapezoid is half the height, sum of the bases. According to that formula, there are 4 parts to it. Area, height, base 1, and base 2. You okay with that? Yes. Which means we know 3 of them. What 3 do we know according to that problem? Area, base 1, and a height. Fill in the blanks. I gotta stop using the screen. It doesn't show up as clearly as I thought. So the area was what, 58? The height was 4. And the one base was, I forgot. 12. Thank you. Something. Solve for the base. What do you have to do? Well, what's half of 4? 2. And I was showing this to the class earlier. There's actually 2 ways you can go about solving this. What's one way? Yeah, distribute. Absolutely, that's one way I can do it. If I distribute out, send it to both parts, we get 58 is 24 plus 2b. And you're back to a very quick 2-step equation. Working backwards means I have to subtract 24 to start, I believe. We get 34 is 2b. Or not Good question. Ooh, I know. And then what do I do now? Divide. Divided by 2, what do you get? You get 17. Okay, super easy. What's the other way you can solve that? What's that? Exactly. The other way you could do this, guys, is that right off the bat, since this is 2 times junk, if I divide it by 2 right away, what's half of 58? 29. And then what? Does it matter which way you do it? No. There's more than one way to solve most of these equations. And a lot of times you guys have been taught, distribute and work your way through. But if you see a shortcut like that, because it is 2 times something, why not make it easier? Just distribute or divide out first. There's no rhyme or reason. Whichever one's fine by me, however you want to do it. It doesn't matter to me. I'm not going to require that you go one way or the other. It's all good. Does that vaguely look familiar? Okay. Let's see. I had another one I'm going to show you real quick. How would I find the area of a semicircle? You take your area formula, and then what do you do to it? That's double it. I want to cut it in half, so I just multiply by a half. Okay. Now, remember, semicircles means just half a circle. So the area of half a circle would be, well, pi r squared over 2. One of the nice things about having that multi-view calculator is that it'll keep your answers in terms of pi. You guys ever notice that? So if I put this in the calculator, I have 8 squared times pi over 2. If you type it in exactly like that, you're going to get 32 pi. Because that's what it does.
It'll have like the sign or?
Yeah, it has the actual sign in there. And that's the huge advantage of having that multi-view calculator. What's that? Let's see. 8 squared pi over 2. That's what you call an exact answer. It's not rounded, it's exact. And that's what's nice. A lot of times that's the solution set that we're going to ask for. We're going to ask for exact answers. Because decimals are boring. Exact answers are fun. Not too terrible. If you don't have this calculator and you have to keep pi in your answer, you know that pi is going to have to be there at the end, right? Can't you just do 8 squared, hit enter, divide by 2, hit enter, and put a pi next to it? No, well you can.
Wow.
You're welcome. Like I said, try to make your day as smooth as possible. For area stuff? Yeah, for yours it'd be the same thing. Because you can create fractions on yours, you know how you hit math, enter, and it'll do fractions and all that. If you do get decimals. So if you get something weird and you know you're gonna have to put pi in your answer, just treat it like a normal fraction. Just remember that you have to put pi in your answer. Okay. So it works out rather nice. Even with that one, it's as long as you know how to convert fractions and decimals back and forth. Because if you get a decimal, yours has math button, right? On the left hand side, if you get a decimal sometimes, let's say you get like 8 divided by 7. Do this. Do 8 divided by 7. No, there's a different way with that one. Hit 8 divided by 7. Hit enter. Hit math, enter. 8 over 7. So then if you had to do that with pi, you would just do 8 over 7 pi. Or 8 pi over 7, how you would remember it. That's the other thing. A lot of times when you're talking about fractions, if you have fractions in terms of pi, one of the things that happens is if you've got 3 halves pi, that's the exact same thing as saying 3 pi over 2. Those mean the same. 3.14159. Yes. And remind me, as we get closer to Pi Day, I'll show you guys this really cool video.
I had pi. I wasn't in school by then. 3, 14, 15. That's kind of sad.
You got it over it.
Like,
Well, that was the area. I was just finding the area of the. Yeah, if we were to do circumference, we would just take the circumference over.
no, we can't. Because those are 3, 14.
Excuse me. The only other thing that I think I wanted to show you was the quick setup here.
9 days.
Get this